Hey, ChemStars, this is Mrs. Vinley bringing you a WSQ 14.8. This one was actually due on Thursday, although you're watching it Friday, but sadly only 14 people have done it by this time on Thursday when I'm going over it. So I don't know if I'm going to be able to answer all your questions. I know I can answer at least one of them at the end. So try to, not procrastinate. Try to do your stuff on time. It'd really help me out if I'm ever absent like this again. So anyway, we are starting with here. If same equation is a 4, I'm using the equilibrium concentrations, and I'm solving for the other equilibrium concentration. So I set up my law of mass action. I plugged in my equilibrium concentrations, and I found that the square root of 1 is still going to be 1 molar. Number 4, just flip-flopped them. So I set up my law of mass action. Instead of making A is 0.5, I made B 0.5. So 0.25 divided by 2 is 0.125. All right, so that's hopefully fairly straightforward. It's the next ones you really have to worry about. So if the initial concentrations are given, what you need to solve for the equilibrium concentrations, you solve using your ICE table. All right, and I kind of set up one here underneath in number 6. So here is my ICE table, and make sure that there's my equilibrium concentrations. I made my AI as my initial concentration of A. I didn't give you that. And I was assuming here, so I could answer number 6 for you, that B was actually 0, which is fairly common. All right. But let's say we have two things here. What if we have initial concentrations for both A and B? And what if K is a big number, like 2? Okay, what do we have to do in these cases? I'll go flip back. I'm doing number 5 at this point. What do we need to do? We need to set up a quadratic equation. So I can show you next time I'm at school the one I have on my phone, because I guess, I'm so techie nowadays. It just says quadratic, it's a green app, quadratic equation. And once you actually do the work, you plug in your A value, your B value, C value, and hit the magic button, and you pick the answer that's a positive one because concentration can't be negative. But I believe I said on the video, what's the good news as far as AP goes? And actually, this was a question on the AP Facebook group that I read all the time. As I think a newbie was asking, do our kids have to solve the quadratic equation? And everyone said no. The AP will always make sure that you can assume like you're going to in number 6. So number 6 down here says in the problem above, what don't you need if K is really, really small? And then I'm assuming that you don't have an initial concentration. So when you do that and you set up your K value, so hang on a second. So I'm using my equilibrium concentrations, if you will, to solve for K. But what do you notice? If your K is really small, and again, the rule of thumb is 10 to the negative 4th or smaller, you can drop, see where I'm pointing right here, point the minus X. Because it's going to be so small compared to the initial volume, it's not, or excuse me, the initial concentration is not going to make really much difference. And so, you multiply each side by AI, take the square root, divide by 2, and you got your X value. So the AP is not trying to kill you with the quadratic. I believe I said that probably 100 times on the video. Well, maybe not 100, but you get my idea. But it is just saying you know what to do in this case, which is really most of the reality. Okay, so again, someone asked what app they want. Like I said, I use a quadratic equation solver. It's a green app that was on my phone. You probably need it for some of the book work, but never on an AP problem. Okay, hopefully that reassured the person who asked me that question. Real quick, if the same thing goes on and what I did, I just used the values for A and B, and I found Q. Remember what Q is? Q is the initial set of circumstances, and it tells you how am I going to shift. So I took 0.1 squared divided by 0.2, and I got 0.05, which is less than 2. So if Q is less than K, it's going to shift to the right. And that's super important for this next question. It's going to shift to the right. So let's scroll down a little bit. Where's my thing? Can't find my mouse. Yoo-hoo. This is embarrassing. I honestly can't find my mouse. Oh, there it is. All right. So here is number 8. Let me make this bigger. I'm using a sample smartboard thing. Yikes. And so unfortunately, well, anyway, I think you get the idea. Unfortunately, it has that smart notebook thing on the side. But anyway, what your ICE table looked like for number 1 or letter A cannot be true. There's a couple things wrong with this. Remember, Q is less than K, so you're not going to add here and subtract here. You're going to do the opposite. So that's why B is wrong. And what else is wrong here is your X coefficient. If there's a 2 here, it's minus 2x in that case. So here we have, at least the signs are right, but again, we missed up this. So it is going to be over here. I'll try to make it so you can see it better. There we go. So letter D is actually the right answer. Okay, so hopefully that helped. Again, I'll should be back on Monday to answer some of your questions, but I just want to make a quick comment. I sure hope that every single one of you is taking this time while I'm gone seriously. Folks, this section, 14.8, is probably the most important section, and 14.9 is probably the second most important section there is in this entire unit. So when you are given your time to work in your groups, please do that. Please stay on AP Chemistry. Do not be socializing. Do not be joking around. I know you guys too well. Okay, I am not there. Hopefully you're treating the sub respectfully and treating your time and your classmates respectfully. So take this section as seriously as you can. This is huge. This section is going to come back to us in chapter 15 and in chapter 16. So pay very close attention. Do everything you can to figure it out. I'll be here on Monday. All right. Hope you have a good weekend. Bye-bye.